Hello, good morning, everyone. My name is Hamoon Ramezani. I'm an application engineer at CAMufacturing Solutions, the providers of A+. Today's presentation will be better DED than scrap. So we will go through the advantages of leveraging hybrid manufacturing in order to reduce your scraps. In this presentation, we will start with some introduction of hybrid manufacturing and directed energy deposition, which will be followed by some real case studies that with using hybrid manufacturing could reduce the scrap on a huge level. So the first case is a worn out impeller case. So we will go through that one. The next one is a T-Connector fabrication, and the last one will be service parts production planning. So on the third one, we will go through the challenges of production of service parts, because usually you would need them for a longer time than your actual production. So at first, let's start with the definition of additive manufacturing. Additive manufacturing is used to manufacture parts through layer by layer deposition using 3D CAD models. There are 7 families of additive manufacturing, which are binder jetting, material extrusion, material jetting, powder bed fusion, sheet lamination, wet polymerization, and directed energy deposition, which can be used for near net shape parts, to repair a part, or to add bosses and feature to the parts. So directed energy deposition uses a direct energy source to melt and fuse deposited materials. There are 4 different types of heat sources for DED, which are laser beam, electron beam, wire arc, and plasma. And also 2 different types of feedstocks. Your feedstock can be a powder feedstock or a wire feedstock. On the left picture, you can see a laser powder machine, while on the right one, you can see a wire arc process. So what is the hybrid manufacturing application philosophy? Because usually when you use directed energy deposition, your dimensions might not look through your tolerances. So you usually want to add a little bit of more stock and then do some post-processing, which is usually just a general machining toolpath, to achieve your finished dimensions. However, in some cases, the tolerances or surface finish might not be a big issue. So you would be just doing your directed energy deposition. But in order to make a comparison between DED and the other additive manufacturing processes, we can consider this example of coloring this drawing. So this drawing, you can color it with pencils and it will be very nice. You will not go out of the borders. So this will be like using the other type of additive manufacturing processes. However, when you use directed energy deposition, there are more variety of parts and materials you can use, but it's like using crayons. So if you want to color this with big crayons, you will probably go out of the border somewhere. It's just like the extra material that you're adding, because your bit material extrusions will be very large bits. However, you can use an eraser in order to get back to what you were supposed to do. So that eraser could be like the machining. So the combination of DED and machining, we call it the hybrid manufacturing. So what is the workflow of hybrid manufacturing? If you want to build a part with hybrid manufacturing, repair a part with hybrid manufacturing, or add a boss to it or modify it, what is your workflow? So the first step is programming your toolpath, which can be done through A+ and MasterCam. So the good thing about A+ is that it works seamlessly with MasterCam. It just adds 2 toolbars to your MasterCam, and then you can do all your additive and subtractive toolpaths all together in MasterCam. After you do that, you definitely need post-processing like any other CAM toolpaths that you make in MasterCam. And then finally, you will build, repair, or modify your part using the hybrid machines or robots that you would have. So as an example, here you can see this spine sliced pipe, which is being printed by a UMC 750 house with a Meltio head. So it's a hybrid machine, which is a package by Philips Additive Hybrid from Philips Federal. And you can see the final results. So this shows that with A+, DED and 3D printing is just not slicing the part. You can do very more interesting parts to do. And even before we get to our actual cases and calculate the scrap reductions, even on this case, you can see if you wanted to use traditional manufacturing method, how much more scrap would you have to make in order to build this spine? So I would like to go to the first case, which is an worn out impeller. So this is an actual case from a client in Italy, and the project was done by CAMufacturing and Primo Additive. So you can see here that the blade of the impeller, they are worn out. And what is it? So do I have to consider the whole part as a scrap and just build a new one, or I can repair it with hybrid? So the answer is definitely you can repair it. If I zoom in, you can see how worn out the blades are. So in order to fix the blades, at first we had to machine every single blade and cut those areas in order to have smooth, good surface underneath in order to build it again. So you machine the worn out areas, and then you will have your additive tool pass. This is a Prima Laser 97950. So we add the machine parts again with additive. All the tool paths are programmed through A+ again. And then the good thing about A+ is that it's been designed for hybrid manufacturing. It understands that in most cases, when you use hybrid manufacturing, when you use DED, you would like to add extra stock and then machine it. So you just add your parameters, how much extra stock you want to add, and it just programs your tool path accordingly. And then this is the additive image tool path. You could see here that you can see the seams and the bits. I will zoom in later to show them more. Therefore, it is necessary to do a surface finish machining. And finally, the machine part will look like this. So you were able to repair the impeller without just getting a new one. So how much scrap did you save? I would like to zoom in actually to see the bits that I was talking about. So in order to do the surface finish, you will have to take care of it. So the estimated deducted scrap by hybrid manufacturing here was more than 125 cubic inches. So that means a lot. That means if you had to just throw out this or recycle it, or your scrap would be actually more than 125 inches more than this, because here all your scrap is the area you cut it already and then you added the material in, and then that a little bit of extra stock that you put for final machining. And the good thing about A+ is your backplot will completely show how your additive toolpath would look like. And then you could just turn on your holder if you wanted to make sure that there is no collision. If you have the actual machine simulation with the post for your machine, you can actually check for the collision. And also you can see the additively part model of the part that how it would look. The second case, it's building a T-Connector. So this is the CAD design of a T-Connector. It is pretty challenging in order to build it because of the shape of it is. But how can we build it? So there are traditional manufacturing methods. One of them is machining. So if you would like to machine this part, you probably need a very big cylindrical initial stock or a very big box as your stock, but either you go rectangular or cylindrical, you can see how much scrap you would have, how much waste you would have. If you want to cast it, again, it really depends on how many of this do you want to produce. Do you want to produce thousands of it or a couple of them, a few of them? And then how much cost and energy it would cost you? Or if you want to do welding and bonding. But how about hybrid manufacturing? How can it be done with hybrid manufacturing? So if you want to do it with hybrid manufacturing, you just need a very, very smaller cylindrical substrate to start. You can do some front and back turning, and then you can use some milling for the flats, make it ready for your boss, and then you can build the boss on top of your on top of the flats. So after building the boss on top of the flat with DED, you can just do the final milling, and then you will have your actual result. So in this short video, I'm just going through the steps and how A+ will help you throughout your process planning. So you can already see without any numbers that the scrap is, the scrap reduction is huge from machining to hybrid. Here you can see the workflow. It starts with turning, milling, DED, and milling. So this is a very typical hybrid manufacturing process. And the good thing for A+ and MasterCam is everything happens in one software, and you can just check the results all together. For example, this is the machine simulation for the milling the flats. But then later on that we will add the material, the AM part model, the simulated bits of your additive toolpaths are completely compatible with MasterCam machine simulation, and then you will be able to use it as your stock model for machine simulation. Therefore, you can understand if you left enough stock or not. And also you can check the backplot, or even you can run the machine simulation for the motion of your additive toolpath in order to see if your tool is acting the way you like it. This is a 3-axis, but in A+, you can do all 3 and 5-axis toolpaths. There are plenty of different toolpaths that you can use. This is the additive part model. You can see every single bit, and then you can save it on different layers. So it's very good to always get back and check your toolpath. And then as you can see, the additive, the AM part model that you make can be used as a stock model for your machine simulation. And after the final simulation, you will have the confidence to do all of these steps in the real life, and we were able to do it with an Optimac lens machine. So I would like to go to see some numbers, because in industry we always like to see the numbers. We have learned not to trust our eyes. So here you can see the scrap reductions for different type of manufacturing methods. So for machining, the volume of scrap for every unit of that T-connector would be 3.47 cubic inches. While if you do it with hybrid manufacturing, it's going to be 1.65 cubic inches. That means even less than a half, almost about 40%. So you have saved up to 60% of the scrap you would make. But even casting, if you're doing prototyping, you would have a huge number of huge volume of scrap. But even if you go up to 20 parts, you probably will have more scrap per unit rather than hybrid manufacturing. But if you do thousands of them, so of course you will have a smaller for scrap per unit while casting it. But if you consider these two numbers, they're still very close. And then what is the cost? The cost of casting, the time of casting. So it shows that even sometimes in mass production, hybrid manufacturing is not as bad as it looks. But if you do a number of them, it's definitely a better solution. So I would like to switch to the last case, which is scrap reduction and service parts. So service parts, how do you want to plan for them? Because in many times you have to provide your service parts years after you're done your production, especially in auto industry. So do you want to just make some of them ready and just keep them in your inventory? How much would it cost you to keep some big parts in your inventory for years? Do you want to keep some of your molds and just cast it during the years? Again, how much does it cost you to keep those in your inventory? But if you have a hybrid machine at your shop that probably you will have to have for different purposes as well, and you know how to make it, whenever you need it, you can just use hybrid manufacturing. So we will go through an example here. From left to right, you can see Hamid Kalami, Sad Zafar, and Chris Darmon, who is the part owner of the Eccentric Autosport in Old Castle. So he reached out because he needed a custom engine valve cover for one of his Mustangs, a 1967 Mustang. So this is the cover that you can see here. And Dr. Kalami, who was a student at 2017, and Sad helped him in order to build this. But what this is actually the design of the cover, and this is from the bottom view. So they did it with machining at 2017, and you can see how much scrap they would have made, and actually they did make because of the shape of the part. So the machine, and they did a lot of scrap. But what is A+ team thinking about is building it with hybrid manufacturing. How would that work? So instead of that big stock to start, you just need, excuse me, a plate, and then you will clamp it. And then you can just build, excuse me again, you can just build the walls and also the cylinders simultaneously. That means with Z layer merge in A+, excuse me again. With Z layer merge with A+, you can build one layer of the wall, one layer of the cylinders, and just go on to the top. So you will make sure you have a good heat distribution, and you're not going to have any collision. And when you do that, the next step is to do the rest of the walls. So you can do that. And the good thing about this here, you can do a surface finish here if you want to make sure you are on your tolerances and on your dimensions. After adding the rest of that, the next step is to machine the outer surfaces. And if you need to machine the inner surfaces, you can do that. If they're not functional, actually, you can just leave them as they are. And the next step is adding these 6 handles to the side of the cover. So they can be done, again, programmed with A+, and be done with using back plane for here, right plane, front plane, and left planes. We can just add these handles. The reason we add this handle is to continue doing the part. So in order to do that, we need to change the setup, the machine setup. We will have to flip the part, and this time just clamp it by those handles that we created. So now we will just have to machine this initial plate instead of the big stock. And after machining that, the only step that we will have to do is just getting rid of this handles, which can be done by wire EDM. And then you will have the final solution. So
Hamoon, you got 2 more minutes, just let you know.
Thank you, Rose. So if we just get to the numbers, you can find out that the volume of scrap that has been reduced is more than nine times. So it's almost 168 cubic inches when you do hybrid manufacturing for that cover, and it's more than 1100 cubic inches when you use machining only. So sometimes using hybrid manufacturing can reduce your scrap on a very big number that you cannot even expect. So in case you have not started to use DED yet and hybrid manufacturing, I do suggest you to start cutting your scrap. Therefore, if you want to know how to, you can be in touch to learn more about A+. You can go to our website at CAMufacturing.com or call our phone number or send us an email, or you can contact your SiCrap resellers and MCAM Northwest. They are all, they will all help you regarding A+. I know I only have probably 30 seconds for the questions. Sorry about that, but if there is any particular question, we can go.
I have one question. So based on your experience, what sectors usually utilize hybrid manufacturing the most?
So based on our observations actually, because it's like very new, all the industries are trying to adapt using hybrid manufacturing too. But the most you have seen it so far is the defense industry and also tooling industry. The industries that repairing would cost you a lot of time and money. It's the one that adapted sooner than the others.